Hello everyone, let's write down the Lewis structure of SO4 2-, that is the sulfate ion. To write down the Lewis structure of any molecule, we need to know the total number of valence electrons. Sulfur atomic number is 16, therefore the electronic configuration is neon, that has 10 electrons, and then 3s2, 3p, 4. We have 6 valence electrons. Neon is the core. And then for oxygen, atomic number is 8, therefore the electronic configuration is helium, that is 1s2, and then 2s2, 2p4. Here too we have 6 valence electrons because both sulfur and oxygen belong to the same group, and helium is the core. We have 4 oxygen atoms, so therefore 6 times 4, that is 24. 1 sulfur atom, 6 times 1, so 6, and we do have 2-, that means we need to add 2 electrons because of the 2- negative charge. So for the 2- charge we need to add 2 electrons. Therefore in total we have 32 valence electrons. So using 32 valence electrons, we have to write down the best Lewis structure for SO4 2-. Now we know that sulfur is less electronegative compared to oxygen. So therefore let's put the sulfur atom at the center, and then let's make 1 bond pair each with the 4 oxygen atoms. We have utilized 8 valence electrons. In total we have 32 valence electrons. This means that we still have 24 valence electrons. So therefore let's put 3 lone pairs around each oxygen atom. If we do that, then oxygen satisfies the octet configuration, sulfur also satisfies the octet configuration, isn't it? Because we have 3 lone pairs, 1 bond pair for oxygen, which means that we have 8 electrons around each oxygen, and for sulfur we have 4 bond pairs. There also it is 8, which means we have utilized all the valence electrons right now. However, this is not the best Lewis structure. Why? Because we have to think about in terms of formal charge. We know that formal charge is equal to number of valence electrons in the atom minus number of lone pairs of electrons in the molecule minus number of bond pairs of electrons by 2. So therefore for sulfur it would be 6 minus no lone pairs of electrons, therefore 0, minus we have 4 bonds, therefore 8 by 2, which means sulfur will have a plus 2 formal charge here. How about oxygen? For oxygen, if we calculate the formal charge, we would get -1 for each oxygen. Let's cross check that. We have 6 valence electrons in the oxygen minus we have 3 lone pairs, that means 6 electrons, because we are counting the lone pairs of electrons, not lone pairs. Therefore 6 minus 6, so that is 0, minus we have 1 bond, therefore 2 by 2, which means this is equal to -1. So each oxygen has a -1 formal charge and sulfur has a +2 formal charge. The net charge we are getting, if we sum up all the charges, we would get -2. SO4 2-. So we are getting the net charge. However, in the best Lewis structure should have formal charges close to 0. So therefore let's bring 1 lone pair to the bond pair. If we do that, then sulfur will have +1 formal charge, but if we bring another lone pair to the bond pair from the other oxygen, then sulfur will have 0 formal charge. Therefore the best Lewis structure for sulfate ion would be this one. Now if we calculate the formal charge, what would happen? We would have -1 formal charge for this one, let me write it in different color. If we do calculate the formal charge, then this will be -1, this will be -1. How about this oxygen? It would be 0, isn't it? Because now the formal charge will be 6 minus, we have 2 lone pairs, therefore 4, minus we have 2 bonds, therefore 4 by 2, which means 2 minus 2, that is equal to 0. So therefore for these 2 oxygen atoms, we are going to have 0 formal charges. Whichever oxygen atom has 2 bonds with sulfur, that is going to have 0 formal charge. And how about sulfur? For sulfur, it would be 6 minus 0 minus, now we have how many bonds? We have 6 bonds, 6 bond pairs, therefore 12 by 2, because each bond pair has 2 electrons, which means 6 minus 6 is equal to 0. So therefore we have 0 formal charge for sulfur. So net charge we are still getting -2, isn't it? So therefore this is the best Lewis structure for SO4 2-. And by the way, when we write Lewis structure of cations and anions, we put the square bracket and write down the net charge outside the square bracket, SO4 2-. So this is the best Lewis structure for SO4 2-. Now what about the hybridization of sulfur in sulphate ion? It is sp3, isn't it? Because the steric number is 4. Steric number is equal to sum of sigma bonds plus sum of lone pairs. Here we don't have any lone pair around sulfur, but we do have 4 sigma bonds. So therefore the steric number is 4, which means the hybridization has to be sp3. And also keep it in mind that we can write as much as 6 resonance structures. We can put it this way. I am not writing the lone pairs around oxygen, but we can write the resonance structures this way. So this is 1, and then we can write the negative charge here and here. So I am just going counterclockwise, keeping this one same, and then we can write one more resonance structure, that would be this one. We can write 3 more resonance structures. So now I have fixed this one and then moved counterclockwise. What I am going to do right now is I am going to fix this one, putting a negative charge, and then going to move clockwise. We already have this, so therefore I am putting double bond here and putting negative charge here, and this is one resonance structure, and then other one would be putting a negative charge here, negative charge here. So this is another one, and then one more thing we can write, that would be this one. In reality, the structure of sulphate ion is the sum of all these contributions. We wrote 6 different resonance hybrid. The original structure would be sum of all these resonance hybrids. By the way, keep it in mind that in SO4 2- we have bond pair repulsion alone. We don't have lone pair repulsion or lone pair bond pair repulsion, because there is no lone pair around sulfur. We have only bond pair repulsion. So therefore the bond angle would be 109.5 degrees. And the other thing that I would like to mention here is sulfur belongs to period 3, isn't it? Which means that sulphate ion belongs to expanded octet category. If you see the Lewis structure of sulphate ion, around sulfur we have 12 valence electrons, isn't it? We have 6 bonds in total. That means 12 valence electrons we have, which means it belongs to expanded octet category. Because sulfur belongs to period 3, it has access to empty 3d orbitals. So therefore, having expanded octet is completely okay for this molecule. That is something I forgot to mention earlier.